Ken. I'm keeping IT here till I get on to the second slide. I'm going to talk a bit about livestock water quality, which has become a huge issue this year. It's always in the background, but we've been doing livestock water testing all winter, which tells you that it's been, producers have recognized the problem and have wanted to have their water quality tested. I'm just going to do the basics here for what we do in our lab. If you have questions, you can ask them. Most of this information is available in a document. Dr. Steve Ansley, who's a veterinary toxicologist at K-State, and I got together and wrote a document on livestock water quality back in 2020. It's available on our website. You can see resources at the bottom of the web page, and you can click on it, and it will provide most of this information. Where do I go? How do I get into the next one, Ken?
So you click on this, and it's
okay. Thank you. I wanted to talk a little bit about water quantity also, which is as important as water quality. It's really an issue now with the drought and the sloughs, the dams, the rivers, streams, creeks drying up. And we have had issues where some of the producers just don't recognize how much water livestock are going to drink in a day. And particularly range cattle, they'll drink 10 to 12 gallons per head per day, or even more in hot weather. Some of these range cattle have been bred to be pretty large lactating dairy cows almost, and so they're going to drink a lot of water. Lactating dairy cows drink 15 to 35 gallons per head per day. Those cows, they estimate, need about 95 square inches of surface area to drink from. They've got to get their nose in a couple inches into the water, and they can drink from 3 to 5 gallons a minute. Not only mama cows and bulls are out there, but some of their calves are on those cows, and those calves drink water too. Smaller calves will drink maybe a couple of gallons to 4 gallons per head per day. And you also have to look at the height of some of those tanks. Can those little calves or slightly larger calves get in there and drink? You may be preventing them from even obtaining water. So it's important to look at how much water is required, particularly if they're going to start hauling, as many producers are. What are they going to need to estimate per haul today? And that's time they're out. They're not going to get that time back, you know, and it's going to enter into some of the harvesting pretty soon, time they're needing, and they've got to be willing to devote that time to haul water if they want to keep their cattle. And that comes to the hard decisions, I think, for some of them. If they don't have pasture, they don't have water, they're going to have to sell cows, and that's a difficult decision for some of them to reach. I also have there what sheep require, a gallon per head per day, laying hens, and pregnant sows. This is straightforward for any laboratory, but I think for producers, perhaps, and for some extension agents, they just don't seem to know that they can contact laboratories for what type of testing they want. Different laboratories have different tests they perform, and the type of sampling, the type of water bottle is going to vary with what analysis is required. What volume is necessary to do the testing? Some only take 250 mils, some will require a liter. Cryptosporidiosis, I think it's 10 gallons or more that you have to ship to the lab. So depending on the test you want, you may have a large volume. And the submission requirements are going to vary with your lab and the test. For instance, blue-green algae, if you take a sample, you generally want to keep it cool and submit it as soon as possible. You don't want to freeze it or you're going to lyse those cells. If your goal is to look at toxins, well, maybe freezing is acceptable. But if you want microscopic identification, if you keep it for any length of time in a hot area, you're going to have senescence of the cells and you potentially lyse them in freezing. And you can contact that lab or check the lab website for that information. Pretty straightforward. One of the comments from Mr. Collins was, what kind of pickle jar do you submit in? And interestingly enough, we do get a fair amount of pickle jars, jam jars, canning jars. I'm sure if you're a lab, you see everything. The one thing that you do need to do is clean that container before you submit. We've gotten pickle pop containers where you can open up that container and you can immediately smell what was in there previously. And then I worry about, do we have contaminated sample and altered results because of previous contamination of that jar. The one thing that almost everybody has is a 1 liter water, plastic water container, and that works really well. Rinse it out in the water that you want to sample, label it, seal it well. You may want to put, they put duct tape around it, electrical tape, paraffin, keep it sealed well. We've had water samples come in some Ziploc bags, which aren't the best. And if you did put it in glass containers, you want to pack it very carefully so you don't have breakage during shipment. But we've had a variety of containers. Those square plastic containers are nice to maybe use to sample, but they're sometimes difficult in the lab to pour from, but they generally don't leak. And that's one of the major issues. If you can get that container into a Ziploc bag or a plastic bag and seal the bag, that's another secondary container. But we get a whole variety of containers, but clean them out before, if they're going to be used a second time, rinse them out in water to be sampled and seal them well. Most of our tests are required that they're filtered. We put them through filter paper. And as you can see from this sample, one of the middle samples provides a good indication that you have cyanobacterial bloom, which accumulates on the filter. But we filter out snails, duckweed, plant material, fecal material, and some of the blooms, the cells from cyanobacteria. And then we can use that water then in our testing. But we do filter our water samples prior to analysis. We just do a very basic livestock water quality analysis. And one of the first things we do is pH. And there are preferred drinking water pH values, ranges out there. They're not scientific. They're based on aesthetics and levels of water pH that would prevent corrosion of pipes. So you want to consider water pHs and what those ranges are. For cattle, it's about 5 or 5.5 to almost 9 pH value. In North Dakota, we have a lot of surface waters that go over 9, and they go over 10. I don't know if any of you have drank water with pH of 10 to 11, but I can certainly tell you it's bitter tasting. The closest it gets to 11, it's irritating to your mouth. You don't want to consume that water. And I've taken it in and spit it right back out. So basically any water over 10, animals will refuse to drink it. And my recommendation is do not use for potable livestock water. And we do have those waters here. When I contacted what Department of Environment, Mr. Collins, the comment was that we have a lot of alkaline seeps here in North Dakota, so we have potential for these very high pH waters. And unless you pH some of them, you probably aren't aware of some of these issues. But it's important to look at that test. We do total dissolved solids, TDS. It's a salinity measurement. Some people don't like it because it's not very specific. It's not sodium or chloride or calcium. It's just filtered total dissolved solids. It's a gravimetric measurement in milligrams per liter. It's not the same as electrical conductivity. They are different measurements. Electrical conductivity measures the ability to conduct electricity, whereas TDS would be not only those solids, but additional solids. So you can try to equate them, but they are different measurements. In this picture, I just put some water from that we've gotten in that was low TDS, less than 100 milligrams per liter, which is fresh water. Some much higher TDS water, 5,770 milligrams per liter in the upper part of the picture. And then over to the right, this is a water sample that we got from a producer, and it had a TDS of over 28,000 milligrams per liter. And you can see when you dry them in an oven, you get a lot of precipitation. And the reason I like TDS is that there is a guide for the use of saline waters for livestock and poultry. And it's up on the screen. It was established by the National Academy of Sciences back in 1974. It gives you a range of soluble salts in the waters of salinity and then comments or effects. And it's a pretty good guide. When you have high sulfate waters, you may have to alter some of the comments, but that's my choice. Why I use TDS is because we do have a guide for livestock. And we have a lot of water, over 7,000 parts per million, which is considered basically unfit for any animal. And I think it's hard for producers to get those results. Again, it's their choice whether they use it or not, but if they use it, they probably are going to find they're going to cause sodium ion toxicity, water deprivation, and death in animals. We do nitrate analysis, and you want to be aware there's different testing forms. You can test for potassium nitrate, which our lab tests for, nitrate or nitrate nitrogen. So you need to know what form is being tested and use appropriate guidelines. Typically, we don't see high nitrates in water. If we see them, they're generally groundwater from water from shallow wells near a livestock facility or wells with cracked casing. However, this year we've seen very high levels of nitrates, and that's typically associated when producers have been hauling water in previously used fertilizer tanks, and they never wash them out well enough, and they kill cattle. In one case, the farmer had killed 30 cows, and there were more down, and he'd backhauled in a fertilizer tank. So the statement, never haul potable water in a fertilizer tank, I think is very valid if you want to prevent death in livestock. And we do have that issue this year. We've had numerous cases where they've hauled in fertilizer tanks, and producers don't think about it. They see a tank, they might know that it came from an uncle or grandfather, they haven't used it for a while, they assume it's fine, put in water, put it out for livestock, and kill them. For potassium nitrate, it's pretty wide range. Usually safe water is under 720 milligrams per liter. Toxic water is over 2,100 milligrams per liter. So it's a pretty easy range to remember. But you also have to consider when you think about nitrates as sources from feeds. And again, you can also not only have nitrates coming to cattle from water, but it can be coming from feed sources, from sorghum Sudan, from oats, from wheat. We're seeing a fairly significant contribution of nitrates to even lethal amounts in feed. The last test I want to discuss is sulfates. We do test that by not a strip test, it's spectrophotometer. We do create a standard curve. We use controls, and then we dilute the samples as required to get them into the standard curve and measure by spec. There are recommendations for livestock sulfate. They're not hard and fast. They're pretty good suggestions. I think the main thing is you have to know whether your cattle have been on sulfate water for a while, and really monitor their performance. Less than 500 part per million in calves is a recommendation. Less than 1,000 milligrams per liter in cattle. Less than 2,000 milligrams per liter they've used for feeder cattle. The problem is that it does have a bad taste. Sulfates do give a bad taste to the water, so you get reduced water consumption. You can have diarrhea from those sulfates, and that's not a good thing with dehydration and the heat. You get poor weight gains. You can have poor reproduction in cattle. Ties up copper, which is necessary for growth and for immune responses. And when it gets over 1,500 parts per million or higher, you have the risk that the sulfates can be reduced in the rumen to hydrogen sulfide gas that can be absorbed into the body, interacts with the respiratory chain, shuts down cytochrome C, energy necessary for the brain to function, and you have polioencephalomalacia, PEM. And those animals go blind, starry-eyed, you can have seizures and death. And we see PEM. We've had comments that they've had blind cattle. The brain turns to basically mush, polioencephalomalacia, and you can't recover those animals. When you have blindness over a couple days, those animals are going to stay blind, and many of them go on to die. So you want to know what the sulfate level is. And a ballpark estimate for North Dakota is that 60% of the TDS is probably sulfates. It varies, but that's a ballpark. There's a lot of requests that can be for other selected toxic substances. We've had, we do not do them, but arsenic. Different areas have higher arsenic, and there are safe limits of concentration of arsenic. We've had iron. Again, there's no value limit, 0.4 ppm for Canada. We've had, interestingly, people have been worried about high selenium. And selenium is not a substance that's found very often in high concentrations in water. You have the Kesterson Reservoir in California that had an issue, but typically selenium isn't a problem in water in North Dakota. But there are other tests that can be done. If you're going to consider total bacteria coliforms, you need to contact the lab ahead of time. We do not run it. You have to have a sterile container, and you need to get it in the lab within 24 hours. Bacteria coliforms, unless it's a grade A dairy, there are no regulations out there. So that's covering what we do for testing of water. Typically, we do have a few additional tests. We do total organic carbon, TOC, looking for pollution, contamination, particularly petroleum contamination. It's a ballpark. We can do ammonia. So we do have other tests, but we don't run those routinely. This is a picture of an algal bloom from Dr. Ensley. Kansas had a lot of algal blooms a few years ago, and they deal with a lot of algal blooms throughout the years. So Dr. Ensley has more experience. He was at Iowa State. He's moved down to K-State, and he shared some of the pictures. Sampling is critical. Where did that sample come from for when they want to look for cyanobacteria or cyanotoxins in the water source? And then what is the risk for livestock? And the USGS has a guideline out there for sampling for cyanobacterial toxins. You have to consider the seasonal pattern. Environmental conditions, did you have recent rains, winds mixing, and the distribution in the water column. The location of the cyanobacteria is affected by the lake, hydrology and morphology. So the USGS publication is very good. I took this from the USGS publications because I never know where water samples are coming from. Are they near shore, which I'm sure typically most of them are? Do you have cyanobacteria bloom distributed throughout the photic zone? Is there a specific depth where that bloom occurs? Is it under ice? So there's a lot of considerations when you want to sample, where to take them. And I think they recently had a talk in the North Central algal webinars on the benthic filamentous cyanobacteria. And certainly cattle get out into a shallow creek bed, slough, they're disturbing potentially benthic cyanobacteria. So most of our samples are coming into our lab. This was a particularly bad bloom of microcystis. Most of them are proactive. They just want to know if the water's safe for use for livestock. Again, no history where it was located. And sometimes they take those water samples, throw it on the dash of their truck for hours, and your sample's compromised. I mean, it's just mush. There's nothing to see. We'd prefer that if you take those samples, note where they're located and keep them cool and get them into the lab as soon as possible. Send them on ice. You don't want to freeze them, but keep them cool during shipment. Ship at the beginning of the week. We do microscopic identification of cyanobacteria. I don't do cell numbers per mil because not all cyanobacteria are toxigenic. Some of them are. If you can do PCR, you may be able to tell whether the genes are turned on, but you have to be probably in a lab or a veterinary college where they have that capability. And not all toxins are cell bound. The microcystins, the potent liver toxins, are largely cell bound, but that doesn't occur with all of them. The other problem is livestock producers don't want to spend a lot of money for an evaluation. They're looking for a quick turnaround. They want to spend not a lot of money, and private labs or UC Davis that do water testing for cyanobacterial toxins, it's going to cost you about $100 to $180 per toxin to look. So if you want to look for all the toxins, you may be spending $400 to $600, and it's just a shot in the dark, and that water sample is just a snapshot in time because it's probably going to change. You get dispersion with wind, those blooms are going to die. They may release the toxins if they've been produced into the water, and those toxins can stay in water for quite a while. So if a producer wants to test for toxins, I give them that information, and it's their call. But I think they probably are spending a lot of money for a snapshot in time. Typically what we see for harmful blue-green algae, what comes to our lab, microcystis in the upper right-hand corner. You have what was previously known as anabina, the string of pearls. Now I think it's dolichospermon in the lower right-hand corner, and aphanosomena in the lower left. That's generally what we see. We see some oscillatoria, which may be called planktothrix now, but those are the main ones we see. And when we have cases that come in, you know, typically veterinarians are considering ruling out the more common causes of animal death or adverse effects. They're thinking about bacteria and viruses. They may be thinking about feed toxins, nitrates and cyanides, heavy metals. You can consider lead poisoning if they've left batteries out for solar fences, powered fences, or they have solar powered fences, batteries that they've taken out of equipment and just left. Pesticides, pollutants can cause certainly some adverse effects. Lightning strikes. We had a case where they had dead cattle in water and they brought in the water immediately, but the water was fine. But the veterinarian went out and posted the animals, necropsied the animals, and felt that it was related to some lightning strikes. But they do often check for water quality and contaminants. Common bloom in the summer is microcystis. The microcystin toxin is a potent liver toxin. It affects the phosphatases in the liver and it causes massive hemorrhage and massive liver cell death. You can also have gastroenteritis and kidney necrosis, and they can also cross the blood-brain barrier and cause neurologic clinical signs. They've had reported cases in Oregon in cattle with mainly neurologic clinical signs related to microcystins. World Health Organization set a microcystin allowable limit of 1 microgram per liter for humans. That was based on, interestingly enough, studying growing pigs. But livestock, we often deal with higher cyanotoxin concentrations and subacute to chronic exposure. So you can certainly have, with fluctuating temperatures, the algae dying and releasing toxins and subsequent growth of another type of cyanobacteria, a lot going on in those water sources. This was anatoxin A. We have calls in dogs too, produced by a variety of cyanobacteria. They can cause muscle fasciculation, seizures, and death. We've had reports in cattle too, but it's very acute. Clinical signs in 5 to 60 minutes post-exposure. Death is rapid. No lesions on postmortem, and treatment is of little of no value. The UC Davis does test for anatoxin A in water and stomach contents. There are lists out there of the different type of toxins related to the target organ. Typically, it's the liver, nervous system, can be skin or general, and the cyanobacteria that produce the various types of toxins. And Dr. Meehan is going to talk about this, the question about what do you do when you have a bloom. The old timers approach was to put barley straw on the water source before you had a hot weather bloom. And Dr. Emsley was down in Kansas when they were putting barley straw on rivers trying to prevent blooms. I think she'll probably talk maybe about copper sulfate. There are a lot of side effects with using copper sulfate. And I guess I don't feel it's very effective with all the side effects. But we do need to improve the type of sampling that we do for livestock exposure. If you can do quick tests for multiple cyanotoxins, it may be a benefit. Long-term answer is going to be described by Dr. Meehan. They asked me what the golden bullet is, and I typically answer it would be groundwater well, if you have enough quantity and good quality water. But they really are struggling out there. That's my talk. I took longer than I said I was going to, Mr. Collins.
That's what I kind of figured. You'd be
Verbose.
yeah, hey, that was good information, and we appreciate it. Yeah, if you can, I believe, stop your screen share.
Have I done that?
I think, yep, there we go. Everything's looking good. Yeah, next up, we have Dr. Miranda Meehan, who's going to talk a little bit about some of the things we can do to improve water quality for the herd and ensure herd health. And afterwards, like I said, we will have time for questions. So if you have your questions, if you want to type them in the chat, be sure to do that. But Miranda, you are free to roll.
Okay, and I'm keeping mine pretty basic, so we can have some time for questions. I'm going to focus on managing livestock water quality, especially during drought. So when we talk about the quality issues, and Michelle touched on one of the main issues, not quality, but related, but just the availability has been a huge challenge for a lot of our producers this year. And this is the same water source between May and June. So this is a pretty common story across the state. But then when we talk about those quality concerns, we're talking about the total dissolved solids, the sulfates, and then like the cyanobacteria, which Michelle discussed all of those. But what happens during the drought is as the water evaporates, the total dissolved solids and sulfates, salt and mineral component becomes more concentrated. So increasing the potential for toxicity or water quality issues. And so within extension, we're having some tools to screen the water, and then based off the results of those screenings, we recommend and assist with lab sampling and sending to the lab. So what our agents have, most of our agents have in the office, and I know some of the soil conservation districts are have these as well, is a handheld TDS or EC meter. And as Michelle said, these measure electrical conductivity, where the lab is gravitational. And so these have a limited reliability, but they can give you an idea that if things are elevated, and additional testing is needed. And so because of how these read, we recommend a sample being submitted if we get a reading above 4,500 parts per million, because once we get above 5,000 with these, our readings tend to level off because there's other things that are interfering with the readings, and it's measuring electroconductivity and not the total dissolved solids. And we want to make sure if we are using these tools that we are calibrating them before we're using them to make them as accurate as possible. The other tool is the sulfate test strips. They seem to be fairly close. There is some variability. I think it's more of a reader error. And so with that 1,000 parts per million threshold, we recommend if we have a reading above 800 parts per million on these, that is submitted to the lab for additional analysis. Obviously, as Michelle said, not everybody follows those guidelines, but that's our recommendation. And so these give us ranges, and it's always greater than. So we can have one that has 800 as greater than 800, and then when it's sent to the lab, we are well above 1,000. Or we've had, the highest these read is greater than 1,600, and we've had some that were sent in and to Michelle, and they came back around 11,000. So these definitely don't tell you exactly what you're dealing with. They just tell you if you should be concerned and additional testing is warranted. Other thing is a visual observation or visual assessment for cyanobacteria. Not everybody's confident doing this. I get lots of pictures texted to me. If this is a possibility, I tend to refer them to the HAB website, which has lots of photos and is a great resource. And then, you know, the recommendation of excluding animals, what are our next steps? And then, you know, yes, we can test, but we're only testing for the presence of the toxins, not toxicity levels, which there's no good information on, as Michelle can tell you, as far as those levels for livestock consumption anyways. There's so many other variables that play there. So in this year, our extension agents, as of the end of last week, have field screened over 800 water samples. Of those, 73 of them have had total dissolved solids above 5,000 parts per million. 93 have had higher sulfates, and we have seen overall just that sulfates have tended to be high, of a greater concern this year. And then 13 have had potential cyanobacteria blooms. Of those, 69 were sent to the lab for additional analysis, and 71 of those producers made some type of management change, whether that was excluding livestock or if it was just deciding to do follow-up monitoring of those water sources to see if they would increase in toxicity levels in the future. This is the results for the samples of total dissolved solids that we've collected. And so anything that is higher is probably from the lab, as a lab result. It's really all over the place. We can have a perfectly fine water source next to one that has an extremely high level of total dissolved solids. So people have been asking me, is there a certain part of the state? Not necessarily. It's highly variable. So, you know, I would just recommend screening and being on the safe side, especially if the screening, if you're working with your extension agent, is free, but also those tools are very cheap as a screening source, and then analysis to itself is very affordable and cost effective versus losing animals. This is our map for the total dissolved or sulfates. So you can see we've had more samples that have had potentially toxic levels of sulfates. Anything that shows 2,000 or greater was from a lab analysis. As I said, those strips only go up to that greater than 1,600 parts per million. So what do we do once we know somebody has a toxic level? What's the next steps for that producer? Immediately is restrict or eliminate access to that water source. Look into alternative water sources, whether that's hauling water, looking at developing a water in the future. I know people don't want to haul water. We've gotten a lot of well, we've never done that before, but this is a pretty extreme drought. I mean, we've had lots of comparisons to 88. And so, yes, this isn't something you want to do normally, but in the short term, if it gets you access to additional forage, I think that's a win. And then looking into those long-term solutions so that you have adequate water and adequate quality water in the future. As you all know, there's lots of assistance programs. I think the top ones, when we think about drought, is the one through the State Water Commission. That one's is very accessible. It's a quick turnaround, so that's been really, really good one. Through NRCS FSA, FSA is the ECP program. Obviously, a county has to apply for that. So the only county currently that has been approved for that was Ward County, and their sign up closed last week. I know there's a couple other counties in the process of applying for that process or for ECP, and that might be available. And so one of the things that it does cover is the development of water. If it's you have quality issues or there's none available due to drought. ELAP is one that we've been talking a lot about with people about in the short term, since it does cover costs for hauling water. While it might not be the ideal solution, it definitely is an option. And then, encouraging people to have those conversations with the soil conservation districts with NRCS about other programs available and looking at the long term and how can we increase and improve our drought resilience so that we're not dealing with a shortage again in the future or quality issues again in the future. Because one of the things is once we have these issues, it's likely that we're going to have them again in the future if we have these type of events because the salts are there. It's just if we have the levels of water to dilute them or not. Short term is that hauling water, tanks, making sure we have barriers, keep livestock out of those tanks. As Michelle mentioned, making sure what we're hauling them in is clean and safe because nitrates typically aren't an issue in livestock water sources, but there are things that can create issues there. Temporary pipelines are another option, and then obviously moving livestock as well. And those long-term options then are those wells, rural water taps, pipelines. And the other thing about these long-term options is not only that the water quality part, but it's also thinking about your operation overall and how can we increase our capabilities to graze areas that we maybe couldn't graze as well before or utilize different resources on our farm or ranch. So when we develop water, one thing we do to do that is improving our livestock distribution. So that's improving their movement across the pasture, their utilization of forages or areas of pasture they maybe didn't use as well or before because they tend not to, especially if we're grazing in the summer, not to want to get too far from that water. So if we have good distribution of water across the pasture, that helps move those animals across that pasture as well, improving utilization of different forages in that pasture. It's going to improve water quality. We're getting those animals out of a water source, a surface water source, reducing fecal matter, urine in that water source. So improving the water quality, but also improving livestock health too. And so when we talk about that livestock health, we know that there's parasites and bacteria that come from animals being in the water. And not only is that harmful for aquatic life and can cause issues for recreation in the future, it also can have impacts on livestock health. And so they can get ill from consuming those bacteria and parasites as well. And so we're not only improving that quality of that water for recreational uses or other aquatic uses, but for those livestock as well. And so even if we're just fencing that water off and providing an access point for those animals so they're not loafing in that water, that can significantly improve our water quality as well. There's been quite a bit of research in Canada that's been done on providing fresh water. This research is showing it's just fencing off a water source and actually just pumping from that water source into a tank, and it reduced E. coli by 66% if they treated that water before putting it, as well as pumping it, it reduced it by 90%. It also reduced nitrogen, phosphorus in that water source, and total dissolved solids. And if we are providing that clean water, not only does it improve health, but it also is going to increase average daily gains. So if we have lower total dissolved solids, we have improved intake of feeds on our animals, which will increase average daily gains. So for cows, researchers are showing up to 0.6 pounds a day. Calves, about 1/3 pound a day improvement in average daily gains when we provide fresh water sources for them. That's really all I have. I didn't want to get in too far into, I didn't think I had time to go into different, like the long-term buffers and things like that to mitigate. And I know you guys have a lot of background in that. And so I wanted to focus more on the immediate concerns.
Thank you, Miranda. One question that did come in and we've had a little discussion on is we have an oil field company that will dump a load of fresh water into dams. Any thoughts on this, good or bad? And if you want to take that, Miranda, that's fine.
Yeah, and Michelle can jump in. So yeah, diluting is an option. It tends to not be the most efficient and effective option. And so we tend not to recommend that. The other thing is if they're doing that, how clean, what are they hauling it in? Because we know that sometimes produced water is hauled in some of that equipment. So making sure that what they're hauling it in hasn't hauled something that could be potentially toxic.
Okay. And that's kind of been the general opinion. And then the other thing that I had mentioned is what's the source? Because just because it's groundwater does not mean it's low in sulfates. It could be higher than what's already there. So yeah, it's important to check that source, test it, make sure it's of good quality for the herd. Any other questions? I've got a few more slides left that I'd like to show some of the materials that are available, but the chat room is open. Likewise, I said, if you want to unmute and ask a question, feel free. Now is the time where you can check it out. I noticed we have some people on from the Water Commission, and Miranda had mentioned the program through them for getting water to cattle, wells, that sort of thing. If they would like to open up their mic and talk a little bit about the program they have to offer, feel free to do that. Well, there we go. I know that guy.
Trouble. For those who don't, this is John Puskowski. I'm the interim state engineer here at the State Water Commission. We do have a program, as Miranda alluded to. It's a livestock drought disaster assistance program, whereby producers can request cost share from the commission for up to $4,500 per project, with a max of 3 projects per individual. That project began on April 8th with commission approval, and to date we have approved just about $4 million in projects with over 900 producers, or over 900 projects, and so we've had great response. Obviously, the issues in some situations are going to be trying to find well drillers and materials and that type of thing, but you know, we do have the ability to request extensions in getting the work done. The work's supposed to be done, I think, within the first 6 months of once they receive approval. But we are anticipating getting approval for an additional $2 million this Friday to keep the program going, because we've just about tapped out the monies that have been approved to date. So again, yes, we do have a program here at the commission, and we have a very responsive staff. These are additional duties that we don't normally have, but we've typically had a turnaround of less than 24 hours to get projects approved and out the door. So,
and to apply for those funds, can you just kind of step them through what is needed so they can explain to their producers?
So there on our website, there's a link to all that's required. You do have to have a letter stating that the federal government does not have you've been turned down by, I'm trying to remember if it's NRCS or FSA, FSA office. Written proof. They need cost share assistance application, a map or an aerial photo of the area where they're going to do this, estimated project costs, and then written proof that you've been denied from FSA. And as I understand right now, FSA does not have a program. We tried to get a blanket letter from FSA so that individual producers wouldn't have to garner these letters themselves, but that did not work out, in that each county FSA office has the ability to start a program at some point in time. So there's been a reluctance to issue a blanket letter. So, but again, we've got a phone number you can call, go on our webpage, and those folks are very responsive and will get you the information you need.
And just looking at the chat, Miranda did put in the link to the Drought Disaster Livestock Water Supply Project Assistance Program. So you can click on that link and save it in your bookmarks so that it's available, and you can inform your producers, which right now would be a large benefit. Thanks, John, for coming on. Appreciate that.
Yeah, one other thing for the good of the group, there's also a couple of other supplemental projects that are going to be considered by a number of different agencies. So we're looking at, a potential rollout here moving forward of some other potential options. So I guess stay tuned at this point in time.
Excellent. And if once those come out, if we can put it out through this group and let folks know, we'd be happy to help.
Yep, no problem. I appreciate that, and I'm sure there'll be press releases through the governor's office as well. So,
okay, yeah, thank you. Question came in from Miranda. Did Miranda talk about copper sulfates, or did I miss it? I just had a producer wondering if it was okay to put in a spring-fed water tank.
So I did not. A few reasons, and Michelle can expand too. It's regulated. It is toxic to aquatic life if it's not used properly. It's toxic to livestock. What it does is can be, and actually, if people don't follow the restrictions on it, what it does is it kills the cyanobacteria, and when cyanobacteria dies is when the toxins are released. So if people don't follow the restrictions and keep animals out for long enough, it can actually increase the number of animals we lose or are potentially impacted by that cyanobacteria bloom. So I have some bullet points that I give to my extension agents that have been getting questions about it, just on the cautions of using it, and then I recommend that they visit with their veterinarian as well. Michelle, do you have anything else to add there?
No, I think you covered it. We've been on this discussion before, and I think it boomerangs back. You can get another bloom, and what they say 7 days. They can be a hardier type of bacteria, more resistant. So there's not a lot of benefit really available for using copper sulfate.
Correct, and then it also kills the critters that eat the blue-green algae. So like Dr. Mostrom said, it can be worse the second go around. I know they should apply, if they're going to apply, they need to look at an applicator's license, which would be through the Department of Environmental Quality, to apply copper sulfate to a water source. So if they're putting it in a dugout or a slough, something like that. Now their water tanks may be different, but it's still one of those things that it looks to be a silver bullet, but there's also a black lining to that silver cloud.
Okay, Kaylee, I just seen your comment to keep moss out of tanks. Another really good option that has less toxicity potential is actually just using a household bleach. And there's, as long as you use that in the right solution, that's a really good option to keep those tanks clean. And if you email me, I can send you some more information on that.
Okay, I'm gonna share my screen again. We're gonna try it. There we go. All right, what you're looking at is an article I came across when doing some research for harmful algal blooms and livestock. And this is an abstract from an event that happened in Oregon where 32 14-month-old steers died in a period of 4 days after drinking from a reservoir during a harmful algal bloom event. So this just reinforces kind of the impact or potential impact that a harmful algal bloom can have on cattle. We've talked a lot about sulfates and nitrates and harmful algal blooms. I just want to emphasize this is beginning, well, it's not beginning, it's right now a current problem throughout the state. There's no one area that's just like Miranda had said, you point to and go, oh, that's where all the blooms are happening, because they're across the state. You'll see here we've got some materials that we give out that have good pictures on what blooms look like. They can be very different, from little grass, what in the lower left, kind of the little grass particle look, to the pea soup look, to just little, basically like little flecks in the water. And then you've got the what turns into the crust on top of the water in the lower right picture. If you want to learn more about that, you can go to the website. This is just a shortcut, but www.tinyurl.com/WMP-HABs. And this information is there. We also have stuff that talks, or information on there that talks about harmful algal blooms for pet owners and ranchers, what it looks like, some of the symptoms, as Dr. Mostrom had explained. For pets and livestock, it's not a happy ending. Rarely is it ever. I did talk to one person this last week that said their dog had gotten in, but they got the dog out quick enough, and it had seizures and a number of different problems, but it did recover. That is the exception, unfortunately. We talked about bottles. Dr. Mostrom had talked about bottles. Miranda had talked about bottles. This is a testing kit that I've put together and supplied to some soil conservation districts throughout the state that wanted to take advantage of it. What it is it's two 500 milliliter bottles. So you can test 2 spots within either a dugout or a wetland area, someplace that your cattle are using for water. If you're concerned with the water quality, it has labels. That's what's down here on the bottom that you fill out, peel off, stick on the bottle, then take your sample. It's best to cover them with like a clear packing tape before you take your samples. That way it doesn't get wet and fall off. It provides livestock water testing guidelines that Miranda and Dr. Mostrom have just put out a new version of that. And the reason they did is that the state lab, state chemistry lab, chemistry division, excuse me, here in Bismarck, has put together a livestock water quality screening that they charge for, but it's available for all producers throughout the state. So that lab has been added along with Minnesota Valley Testing, Astrochem Lab, and then the diagnostic lab. Also in there are custody sheets that say, here's who took the sample, where they took the sample, and when it was sent. And all that goes into the cooler, like Dr. Mostrom had pointed out, in a cooler with ice packs and sent to the source that you would like to test them. Talking with Jim Kornstrom from our lab, he said they have performed 2 different livestock water quality tests for producers just within the last couple weeks. So people are taking advantage of it. Miranda had posted a link to this document, the testing guidelines. It's a very good document because it tells you step by step what you need to do as either a producer or somebody that's going out to help the producer take that water sample. So these are available. I know Miranda has made bottles available to her extension agents, a number of them throughout the state. They're the 1 liter cubes, or 500 mil cubes, I believe. They're very compact, so they're easy to carry around. Little somewhat harder to collect a sample because they're kind of flimsy, but they work good. they function just fine. And then there's also this option. And then here's a look at what the water testing guidelines look like. It's a one pager, so it's easy to read. It's not something that you have multiple pages, but steps 1 through 8, how to, and I will emphasize for all labs, do not use regular ice. Use an ice pack, the blue ice that you find at Walmart, a couple, 3 of those in a 6-pack cooler with those 2 bottles, and you're good. Also, one thing I will remind folks is make sure you put a label in there with your address on so that the lab can send you the cooler back if you'd like to have it. Most people do, so include saying, please return cooler to, and write your address in there so that they can do that. And then it gives the shipping instructions, where to ship for all 3 of the labs. Let me cook this off. Stop sharing there. All right. Are there any other questions for Dr. Mostrom or Miranda, myself? We've got a little bit of time here to take some questions. One last thing I'll mention, I wonder if I can pull this up. We'll do it one last thing because I like sharing information so everybody gets a chance to see what's out there. What you see is the website that the tiny URL takes you to. If you go in here, you can find the information. If you scroll down a ways, it will say a current list of lakes and then a harmful algal bloom map. If you click on that map, might take a little bit here. It's working pretty hard. There you go. This is what you get. This tells you what lakes we have had reports from, which ones were under investigation. So we were gonna sample Boom Lake, Barnes Lake, Audubon, Crooked. The investigated but low toxin level lakes will be here. So you can see where those are at. Luckily, some of our habitual offenders in terms of harmful algal blooms have sampled low this year. And there's others that we hadn't heard of before that are sampling high. So you can go in here and go under current advisories. This will tell you where our advisory lakes are. If you click on this, it tells you what the advisory means. And then our warning lakes. And so far, cross our fingers, we have not hit any lakes that have warnings on. So this is one resource that's open to everybody. I encourage you to check it out and use it as much as you need. There's also, I'll back up here, a way to report a bloom. So if you go online, this works best with a smartphone. But this is what the reporting form looks like. It will take the GPS location off your phone. If you refresh it, and then it will fill this in automatically, so we know right where to go, where the bloom was. You can add pictures down here, and people have been using this, the general public, and I haven't had any complaints that it's hard to use. So they've been submitting reports. What was it? Just the last couple days, we had some from Crooked Lake and then one from Devil's Lake. And that's how we respond to the harmful algal blooms when we go test for them. All right. Well, I don't see any other questions in the chat room. So I would like to thank everybody that has been online to attend the web shop. One thing I will do is put a plug in for the next couple web shops. In October, we will be looking at our lakes rivers and wetland surveys, so natural or national resource surveys that we do. And then in November, what's scheduled is PFAS, which is a long name that my tongue trips over every time. So I will leave it at PFAS, PFAS. And I will let you guys do the Google search on that. So I'd like to thank everybody that has attended, and we will see you in October. Thank you, Dr. Meehan, and thank you, Dr. Mostrom, for all your information today.